Hello and welcome to VisugXL. My name is Peter Hazens and I will be your host for today in stage 2. We are happy to kick off this virtual conference with more than 400 registrations. It's good to see that people are still willing to free some time in these crazy times to learn and to share their experiences. Our user group activities will continue in a virtual fashion until we are ready to host in-person events, again in a secure and healthy way. For the first time, we are using Pine as the platform to host this virtual event, and we hope everything works out as expected. Please contact me or someone else in our team to help you with any question you might have. During the different sessions this afternoon, you can use the chat window to share info with other attendees, and please use the dedicated Q&A tab to ask questions to the speaker. We will try to cover a few of these questions at the end of the session. So please don't forget to rate the session afterwards so we can collect all your feedback. So without further ado, I would like to announce our speaker for the next session. Erwin Staal will give a deep dive on Azure Resource Manager templates. Enjoy.
All right, thank you. First of all, thanks for having me. It's a pleasure giving this presentation. Thanks for joining, of course, in this session. So for the next 60 minutes, 55 minutes, we're going to talk about the Azure Resource Manager and about the ARM templates specifically. So my name is Erwin Staal. I'm an Azure architect and DevOps consultant from the Netherlands. And I work for a company called 4.net. We do consultancy and training, etc. Kind of all based on the Microsoft stack. So we'll first look a bit at the Azure Resource Manager here. I have a few slides prepared. Then we'll switch to Visual Studio Code to actually look at how can you create the templates and what features do we have. And then at the end, we will spend a few minutes on looking at how can we actually deploy the templates, what does that look like in Azure DevOps, and how can we use the Azure portal to troubleshoot the template creation, etc. So first of all, what is the Azure Resource Manager? It is the deployment and management service in Azure that allows you to enable, create, update, and delete your resources. So it's basically a REST API that you can use to manage all the things you run in Azure. It's also your entry point for things like role-based access control and policies. So if you want to restrict who can do something and want to restrict who can do what, that's also done through the Azure Resource Manager. So if you as a user would like to interact with the Azure Resource Manager, you could actually talk to it directly since it's a REST API. So you can just call into it directly. But there's also various other ways to do that. For example, you could use the portal to create your resources, and that will then call the Azure Resource Manager API. But there's also the Azure CLI, there's also PowerShell, and there's even a few SDKs in different programming languages, which allow you to deploy your resources from code. So for example, you could be creating your SQL databases or servers, etc. using C#. But you could also deploy an ARM template from C#. So you actually have quite a lot of options. And last but not least, we can obviously deploy our resources using the templates we're going to discuss today. So when you instruct the Azure Resource Manager to do something for you, the Azure Resource Manager gives that work to something we call the resource provider. And a resource provider, we have a resource provider for virtual machines, for example, and we have a resource provider for SQL, which allows you to create a SQL server or the databases, for example. So there's different resource providers in Azure, which all cover a different set of resources underneath them. You cannot call into these resource providers directly, although they are a REST API, but you have to go through the Azure Resource Manager to do that. So when you start deploying basically any resource to Azure, using any of the previous mentioned ways to do that. You can do that at various levels within Azure. So there's a resource grouping going on there. So first of all, we have on the top management groups, and then we have one or more subscriptions within these management groups, and then we have the resource groups, and in the resource groups, we have the actual resources. So you can deploy various things at the different levels, and there's also a hierarchy going on, meaning that if you restrict access to something on a subscription, for example, that also flows through the resource groups and resources as well. So that allows you to deploy a policy, for example, on a subscription level, or deploy a policy on a management group level and have it apply to whatever is underneath that resource, that grouping in the hierarchy. So what then are the ARM templates? The ARM templates are a declarative code, which is JSON here, for describing your Azure resources. So that means that whatever you write in your template, that's how your resource is going to be. And the deployment model will make sure that it's also been deployed, been done in an idempotent way, meaning that if you would deploy the same template 10 times, the end result would be 10 times the same. That is different when you start managing your resources using the Azure CLI, for example. Then you have to take into account that a resource might or might not already exist. You don't have to do that in ARM templates. You can just deploy it 10 times and it will be 10 times, give you the same result. So it makes managing the lifetime here a bit easier. So it does allow you to centrally manage all your infrastructure, especially, of course, when you put your templates in version control. That also allows you then to go back in time and deploy a previous version of your infrastructure, just as you would deploy a previous version of your application, for example. And by putting it in version control, you also get the benefits of doing testing in the pipeline, doing pull requests for validation, etc. So by putting your templates in version control, you get all these nice benefits. So without further ado, let's move into VisStudio Code to look at what templates actually look like and how we can start building them and how VisStudio Code can help you to actually do that. All right, so for those who've never seen an ARM template before, this is the basic structure of a template. So a template always contains what you see here. So the first few items are basically a bit of metadata. It's the schema, the version, and the API profile you're trying to use. That's not that interesting most of the time. However, the version here in the schema is being used by the VisStudio Code tooling to provide you some help. So you probably want to be up to date with the schema version here. But it gets more interesting down here in the parameters, the variables, the functions, the resources, and the outputs. So first off, the parameters, that's where you define your inputs. So that's where you define the data you want to get into your template whenever you start deploying it. The variables are also what you would probably in code see as a private variable. So that's where you can store data that you would like to reuse throughout your template. Then we have the place where you can define functions. We'll come back to that in a bit. And then the most important part of the whole template probably is the resources array. And this is where you define the resources you want to create. And last but not least, there's outputs. Because just as we have the parameters to put data into our templates, we also have outputs to give something back after deploying the template. So if you would, for example, deploy your template using PowerShell, then the output of the template would be feedback into PowerShell, so you can use that information to do further processing. So let's have a look at what a simple but yet complete template might look like, and let's have a look at a bit more detail on the various things we just touched upon. So first of all, the parameters. As mentioned, that's the input into your template, and they always have a name. Here's the storage queue. You define a type. So here it's been defined as a string. But as you can see, there's other options as well. We have arrays, booleans, integers, objects, two secure versions of the string and the object, and just a basic string. So as you can see, there's also a bit of help from Visual Studio Code here in writing these templates, and that's because I've installed the ARM template extension on Visual Studio Code. Makes your life a lot easier here. You can also define the allowed values, so that helps you with validation. If you would deploy a template and you would supply a value that's not in this list, you will get an error on that, and also helps you with auto completion with the values over here. You could supply a default value so that you don't have to provide a value all the time, making the parameter optional. And you also have the ability to provide a bit of extra data as a description, for example. So if you would later on then use that parameter, it would normally show you, this one over here. It would show you the description that you've typed above to help you give you a bit of more information on the parameter you're using. So this is actually how you would start using a parameter. You do that by using the parameter function in an ARM template, and then specify the name of the parameter you want to use. And that's how you can then later on in your template use that particular parameter. So we also have the variables. They are kind of similar to the parameters. You can define them by using a name. And you don't have to specify a type of whatever, because you just specify its value right away. And as you can see, here again are a couple of built-in functions being used. So there's the concatenation value function, there's the toLower function, we have a unique string, a resource group function. So there's all kind of functions already built into the ARM templates that you can use. And using a variable is actually kind of the same as using a parameter. You just need to use the variables function this time and provide it with the name of the variable you wanna use. So over here we have a very simple definition of a resource. And defining a resource always requires specifying its API version. All the resources, all the resource types have multiple API versions. You always have to specify the one you want to use at that point in time. So you have to specify the resource type. So here I'm going to create a storage account, and that lives in the Microsoft Storage Resource Provider. You always have to provide a name, and you always have to provide a location. And this is the location, the Azure location your resource is going to be deployed in. So that's actually quite a list these days of locations, data centers you can deploy your templates in, your resources in. So those properties over here are kind of always required on whatever resource you are creating at that time. And then you always have a few properties that are specific to the resource you're trying to create. So here the kind property, for example, is here specified storage v2, and that is a specific thing for a storage account. Same as the SKU, that's also a specific thing to a storage account. So that's how we can define a very simple, straightforward resource. Then last but not least, there's also the outputs. And as I mentioned before, that's to give some information back to whatever tool you were using to deploy your template. So you could be deploying your template using the Azure CLI, or you could be deploying your template using PowerShell or Azure DevOps. Doesn't really matter. But the output you've defined here will be feedback into the tool you're using to deploy, and you can use it then there to do some logging or use it in further processing if you like. So defining them is kind of similar, looks a bit similar to the parameters. You have to specify the type you're going to give back, and then you obviously have to provide a value. And this is something that you see done often, which is giving back the resource ID of the resource you just provided. So that's the actual path, you could say, to the resource you just created, so that other processors later on can use that resource to do additional processing. So this is what a basic ARM template looks like. It has the outputs, it has the resources, variables, and the parameters. The only thing we didn't touch upon here is the functions. The functions field, the functions array, allow you to define your own functions. We already saw a few of the built-in ones, like the concatenation and the to lower, and we'll see a lot more during the rest of the demo. But you can also define your own if you want to, and that's especially helpful if you find yourself repeating a lot of functions, same function pattern all the time. But they aren't too useful, and that's because you can't reuse functions across templates. So what I mean by that is that I've defined a function here in this specific template, but I cannot use it in another template without copying it, of course. So the function is only available in the template in which you define it, and it makes it not that useful. But it's something you could do, and I've used it once or twice because it really helped me out there. All right, so that's kind of what I want to talk to you about for an introduction on how an ARM template could look like. Let's dive into the more advanced concepts here to make it a bit more interesting. So we already talked about the functions, and we already saw a few built-in functions, but there's actually an enormous list of functions, built-in functions available for you. And what you see here is a list of functions that I find myself using quite a lot. But in the Azure documentation, you can find a lot more. But I just wanted to mention a few of them to get across what you can expect here. So, of course, as we have arrays, an array type in the parameters, there's also functions to work with the arrays. So there's a function to query an array for a particular value and see if it actually exists in an array, or if the array potentially is empty. There's the equals and greater than comparison functions, and there's more comparison functions, but these are the two that I find myself using most often. So they allow you to see if a particular value equals another. So I often use that one in doing templates to different environments to figure out where my template is going to at that point in time. So if I would, for example, deploy something to my production environment or to my test environment, I sometimes use the equals function to modify the name of the resource, for example. So then it comes in handy. There's a date function to get the current date. We already saw the parameter one. There's a few logical functions, like an if and an and and an or. We'll see them later in action. We have a few numeric functions. There's functions to work with objects to see if a particular property is defined on an object, for example, or to union two objects to combine them. And these are also very handy, the resource functions. We already saw the resource ID function to get the ID of a specific resource we just created. There's also a function that gets information on the resource group you're currently deploying to. So if you were to deploy your resource in a group, then you could fetch its name or its identifier or the subscription it's in, stuff like that. The same goes for the subscription function, allows you to get the ID and the name of the subscription, etc. And one that I find very useful is the list keys one. And that allows you to, if you have created a storage account, for example, then the list keys function allows you to fetch the keys, the access keys in that storage account. So what that allows you to do is, after you create your storage account, you can fetch the access keys and then in your template, push those access keys into KeyVault. So you don't have to do that manually. You don't have to do copy, pasting, or whatever. You can just grab it from the storage account using the list key function and then push it as a secret into KeyVault right there in your deployment. or feed it to your app service, for example. And there's a few string functions which I especially use in creating the names of resources, etc., etc., etc. So these are some of the built-in functions that I find myself using quite a lot, but there's a lot more, and I'm going to show you the list, or at least point you to the list later on. So another feature I use a lot is that of the condition. And condition is specified like this, and it allows you to specify whether or not this particular resource needs to be deployed. So it expects a true or false back from whatever you specify here, and then deploys the template or does not. So for example, I use this in scenarios where I deploy to multiple environments. And although I want to keep my environments mostly the same, so my test environment should be mostly the same as my production environment, we cannot always do that. Sometimes that's because of security, sometimes that's because of cost, making a test environment way too expensive. So then you could use the condition to specify whether or not this particular resource should be deployed here during this deployment. So that comes in handy quite often. So another thing I wanted to let you know while we're here in this template is that you can actually specify resources within resources. And that's what we then call a sub-resource. So this is the root level resource here. And in that root level, we are creating a SQL server. But here, that SQL server has resources of its own, and that allows us to deploy the firewall rules on top of that SQL server, here defined as a sub-resource. So that allows you to specify, kind of make a grouping of the resources that kind of belong together. And since I'm now specifying this as a child resource, a sub-resource, I don't need to specify the whole type here. I don't need to specify Microsoft.SQL/server/firewall rules. I can just do firewall rules because it's a sub-resource and it will infer that on its own. Something I forgot to mention about the conditions is that although this condition might lead to false, meaning that this particular template, this resource here, isn't going to be deployed, you still need to make sure that you provide valid values in parameters and variables you would normally use in that resource. That's because they are loaded and calculated no matter what the value of the condition specified here. So keep in mind that this must be a valid value, although this over here might actually lead to false. Or you will get an error on it. All right, next up is something about ordering. You can probably imagine that a lot of resources in Azure actually depend on each other. I cannot deploy a SQL database if my SQL server isn't available yet. So I need a way to specify what resource needs to be deployed first and what needs to come second. The way to do that is to use the depends on array to specify on what other resources should this deployment wait before being processed. And there's a few ways in how you can specify the resource to wait for. One of them is using the resource ID function, like we saw earlier. And that is especially helpful if you want to wait for a resource that you did not define in this particular template, but it has been defined in another template. Then you want to use the resource ID to make sure it's available. If you want to wait for resources that are defined in the same template, then we can actually just use the name of the deployment, for example. So that would be the name specified here. But we can also use other functions to get to that specific name and wait for that deployment to happen. So there's multiple ways to do that. So one additional thing on that is that if we quickly go back to the conditions here, here I did specify that same resource, the firewall rules, as a sub-resource. So you might think that because you did that, the deployment is smart enough to understand that it should deploy the SQL Server first and then the firewall rules, but that's not the case. So even when defining a resource as a sub-resource, you still need to define its depends on, otherwise it's going to deploy them at the same time, and that is obviously, at least the first time, going to fail. So although it's a sub-resource, you still need to specify the depends on. All right. When you start building these templates, and especially when you start creating more and more resources, you will find yourself in a situation that your template becomes enormous. It becomes quite big, quite quick. That's obvious because of the usage of JSON. It's quite a large language, you could say, by itself. So in the examples I've showed you today, it's quite all right. They're pretty small. But if you, for example, were to deploy an Azure VM, for example, then, as you can see, you need quite a lot of resources to be able to do that, and your template becomes quite big quite quickly. That's actually a feature that comes from the Visual Studio Code extension, which allows you to insert template snippets and work from there. That's a cool feature. But it also shows you how quickly a template can become very, very large. So there's actually a way to overcome that and to work with, to create smaller templates that are reusable, and to create templates that just deploy a specific resource and make a bit more of a modular way of building your templates. And that's by using something that we call a linked template. And what you then basically do is that you specify a URL to another JSON file, another template that you want to have deployed here. So that allows you to specify the creation of a storage account in another template and reuse that here and in other different projects you might have. And that allows you to nicely organize your templates. We will get back to that organization of your solution later on in part 3 of the demos. But linked templates allow you to do that. Create nice components and reuse them. And you can do that by just specifying the URL of another resource. And the thing is that URL needs to be publicly available, of course, or at least publicly you can secure it, but your template, your deployment needs to be able to access it. So what you will be often doing, what's probably most easiest way to get around this, is to deploy your templates into blob storage and then call the template from blob storage like I'm doing here. And in production, you would then secure this URL because you probably don't want to put your whole infrastructure on the street. So you can then secure this using a token, for example, and make sure it's still only privately accessible from blob storage. So that's how you can then use the linked templates. Another thing I wanted to mention here is that I've specified a deployment mode here. And in the deployment mode, there's 2 options. There's the incremental, which I'm using here, but there's also the complete deployment mode. And the incremental means that the deployment will only deploy and touch the resources you have specified in your templates. So if you have a resource group and that resource group already contains a few resources that you haven't specified in your template, then they will not be touched. Only the stuff that's specified in your template will be touched. If you use the complete mode, however, then all the stuff that's not specified in your template, but does live in your resource group, will be deleted. So the end result in your resource group will be as specified in your template. So that's a mode. The complete mode allows you to be really, really specific about what a resource group should look like. But you also need to be really sure about what's there and that it's been configured correctly in your ARM templates. because you will lose whatever is not in your ARM templates. So you have two modes of doing things. And that complete mode gets a bit more complex when you start deploying resources from different templates into the same resource group. So you might want to be careful with using that complete mode. Talking about deployments, as we mentioned before, you can do your template deployment using various tools. You could deploy your template using the Azure CLI, PowerShell, Azure DevOps, even C# if you wanted to. But there's also, luckily, a way to, before you actually do a deployment, see what the impact of that deployment is going to be. And that can be done with, in PowerShell, the what-if switch, or in the Azure CLI, the what-if operator. And this is then a result of what you would get if you would run that command in PowerShell. It will show you what changes are going to be made to your resources and allow you to validate if that is what you actually want. This feature is still in preview, and there are a few known false positives, so you need to work around it. But at least it gives you an idea of what is going to be changed during a deployment. So that's definitely something you and I find myself doing a lot, using during local development. I do a what if to see what the changes are going to be and if that's what I really intended it to be. All right, on to the next subject. All of the deployment examples you've seen so far are all about managing your resources in Azure. But what about managing more of the data side of things? Well, the answer here is quite short, and that's you can't. ARM templates are always work on the control plane and not so much on the data plane in Azure. So they allow you to create resources and manage your resources, but they don't allow you to work with the data inside of a resource. So, for example, you can't seed a database with values using an RM template, or do a few other things I specified here on the top, like especially this one I find annoying, is that you can't create objects in Active Directory using ARM templates, so users, groups, whatever. And I also have found myself in the situation where I had to load a value from a third-party service and put that in a deployment. That's also something you obviously can't do with an ARM template. So there are situations where you need a custom script run during your deployment to do something for you. And luckily, there's quite a new feature in Azure templates, ARM templates, and that is called the deployment scripts. And the deployment script, deployment resource, allows you to run a PowerShell script or Azure CLI script during the deployment of your resources. So you could call into a PowerShell script, have that do something, and then come back with the result and continue in ARM templates. Before we had this feature in ARM templates, what I then used to do is run a PowerShell script in my Azure DevOps pipeline and then feed that result into the ARM templates. But now I can do that from within my templates, which is a bit nicer in terms of having one solution, one thing to look at to get to the actual truth of my infrastructure. So that's what you can do with the deployment scripts. Call a bit of PowerShell or Azure CLI during your deployment. Talking about working with data and more of the data plane side of things, there are two extensions that I want to quickly touch upon. The first one is the extensions on a virtual machine, and we will come next to extensions on SQL. So first of all, the extensions on the virtual machines. There's a few third-party extensions that you can install on a virtual machine, and there's also a few extensions by Microsoft. And I've especially used this particular one a few times. It's the custom script extension, and that allows you to run a script on your VM from your ARM templates. So, for example, when you create a virtual machine, you probably need to do some configuration inside that virtual machine to make it actually work. You might want to install some specific piece of software or hook it up to your PowerShell decide state server, things like that. And this extension allows you to do that. So after you create your VM, you can install this extension on top of it, and it will run the file that you've specified, or run the command that you've specified here to work inside of that VM, which is something you can't normally do straight from an ARM template. The same kind of goes for the SQL extensions. Again, you normally can't work with the data side of things. So the data inside of a SQL database, you can't do anything with that from within an ARM template. But luckily, we have an extension available that, for example, allows us to import a DACPAC. So it allows us to import a backup of our database after we create a database resource. So that allows you, for example, to create a database resource, and then right after doing that, it allows you to import some basic database schema, etc., right from your ARM template. So that's a feature that's quite useful. It's obviously still a bit limited to what you can do, but at least that allows you to put some default data into the database. All right. Next thing I want to talk about is how do you handle secrets within your templates. So first of all, we already saw it in the beginning, is that we have a specific type for the parameters, which is called a secure string, that allows you to put a password, for example, as an input in your ARM template. And what that secure string basically does is that it will make sure that the value you provide will never be put into any log and never be showed anywhere in the Azure portal, for example. So at least you know that you cannot get back to the password through logs or something like that. So that's a start. So that means that if you deploy your template, you could provide a secret, for example, coming from Azure DevOps, and have it work with that in a kind of secure way. But it's better and probably more secure to use KeyVault to store your secrets, to store your passwords. And a nice feature we have is that instead of defining that the type here and say it's a secure string, we can also reference KeyVault and a specific secret in KeyVault that will then be loaded at deploy time of the specific template. So what you need to do is you need to specify the KeyVault you want to use, and then you need to specify the name of the secret you want later on in your template. So that allows you to fetch a secret from KeyVault and use that instead of having to push that into your template using a parameter. There is one downside here to this approach, and that is that you have to specify the full resource ID to your KeyVault here. And that is because in parameters, you cannot use functions like the resource ID or the resource group, etc. You can't use them in your parameters. You can only use them in your resource section. So that means you have to specify the full ID here. And sometimes that's okay, but if you have multiple KeyVaults, you actually need to be you need to be able to define different ones. Then it becomes a bit more annoying. So there is a solution to that, and that is to put the deployment in a linked template, which we already saw. And then you can actually specify the parameter here. And since you are done in a resource and no longer in the parameter section, you are allowed to use the resource ID function. So you can dynamically query the name and the ID of the resource you want to use instead of having to specify that hard-coded. All right, so that's a little bit about secrets and working with KeyVault. You do need to enable a feature on your KeyVault to be able to use this. So that's a checkbox you need to apply to be able to use the KeyVault during ARM deployments. And you also need to make sure that the identity you use to do the deployment. So if you, for example, would do the deployment using Azure DevOps, then you use a managed identity, a user in your Active Directory to do the deployment. You need to make sure that that user is allowed to read the secrets in your KeyVault, has access to them. Otherwise, it obviously can't fetch the secret and use that. All right. We already talked about a few parameters. We saw the string already. We saw a Boolean, but there's more complex types, namely the array and the object. So when things become a bit more complicated, you quickly find yourself wanting to use arrays or objects to specify your input. And luckily you can. And this is what that could potentially look like. This is a definition of an array. And what I'm trying to do here in this particular template is to create multiple storage accounts. So what I can do is I can, in my parameters, specify the values of the storage account, and then during the deployment, use what we call the copy command to iterate over my array. So using that array in combination with this copy command allows me to create a particular resource multiple times, just by specifying that on the root level of the resource I'm trying to deploy. And this is then how you can actually get to values within that array. So there's a copy index function, which will give you the current iterator into your array, and that allows you then to get a specific entry in the array, and then, for example, fetch its name, since what I've put into the array is an object, and this object has properties. So that's kind of cool. Then I can reuse this particular template, this piece of JSON, to create multiple instances of a particular resource. And I can do that both in a serial or parallel way. So I could just create them all at once, or maybe I want to create them one by one. There are some resources that you cannot create in parallel. You get conflicts if you do that. So then you might want to say that you want to do it serial. But you can actually also specify that you want to do them 2 by 2, or I could do them actually 1 by 1 to actually have it done one at a time. So you can play around with that. Most of the time you can just do them all at once, just in parallel. But sometimes you can't, and then there's the serial option to overcome that. So here I've used the copy command on an actual resource. So this will create multiple instances of the storage account resource. But you can also actually use the copy command inside of your properties. So if you have a resource, here, for example, a virtual network, this virtual network has subnets, and that subnet is an array. So I could actually use a copy to create that subnet property and to feed that with an array. That copy command itself is also an array. So if I would have a resource that has multiple arrays in its property section, I could actually do that here as well. And be warned that there's actually a bug in how the ARM templates are being processed. If you would do this, if you would create a second copy command at that root level, then as you see here, Visual Studio will complain about that, because you shouldn't do that. But you can actually deploy this template without getting any warning or error. And what then will happen is that the second copy command will win. So it will simply remove the first copy command from your template, and the second one will win. So I've been staring kind of blindly at a deployment once because I couldn't explain why a particular property wasn't injected into my template. And this was why. I specified this twice, and then the first one will simply be deleted. So nowadays, luckily, we have a Visual Studio Code to warn you about it. But as I said, the deployment will still just succeed. All right. Last but not least, we can also define tags on our resources. And this is how you do it. It's just another property on a resource, and tags allow you to add a name, key values to your resource as specified here in the parameters. And I find those especially useful in the Azure portal while I'm querying my resources to see what do I spend on my dev environment resources, for example. So if you go into the Azure portal and go to the cost dashboard, you can actually filter on your tags and then see what, for example, your environment dev will cost, etc. So they come in handy there. Another thing what we use tags for is that we have specified a tag called do not delete on specific resources in our research and development subscription. And every night we delete whatever is in that particular subscription except what has a tag do not delete. So there's various ways in which you could use tags and where they would come in handy. All right. So I hope you've seen a few nice examples of how to build templates and what kind of functions we can use to do that. Let's have a look at how we can actually work with the templates in a bit larger project. How would you structure your project? And if once you have structured your project, how do I then actually delete my project? Deploy my project. Of course, we also need to delete our resources. Sometimes projects do end, but deletion is actually something that you cannot do with an ARM template. So you have to find another way. All right, so on the structure of things, what I always tend to do is that I always create two folders. One is the composing folder and one is the nested folder. The nested folder contains my very small single responsibility modules, you could say. So if we would dive down into the storage one, for example, then you find a storage account v2 template, and this template does nothing more than create a storage account. And in that same way, I also have a template that does nothing more than create a SQL Server database, for example. And then I use those templates in something I call a compose template. So, for example, I always have a main template. This time I called it application main.json. And that main template might call a nested template. So might call one of those single responsibility templates. But it also might call another compose template, which then might call into other nested templates. So as you can see, there's kind of a tree structure here in how I create and structure my solution here. So to make it a bit more concrete, I have my application main. That's always the starting point of my deployment. So this is the file I'm actually calling from Azure DevOps, for example, when I want to do a deployment. And if we look at what's defined in there, then the first thing we find is an Azure KeyVault deployment. And that one calls into the nested folder to directly deploy a KeyVault. Second, there's access policies on KeyVault. That's not too interesting. There's an app configuration being built. Again, that's just a nested template from this nested folder here. But then I would like to deploy my web app. And my web app, again, consists of a server farm. I always like to use application insights, and I need to deploy one or more app services itself. So that means a few resources that kind of form a group and also always have the same life cycle. You can always deploy or modify them at the same time. So I group them into what I then call a component template, which is this one, for example. and that will create me the application insights instance. It will create me a server farm, and it will create me an API, and it will create me a UI, a client. And that particular web app.json is then being called from my main template. So that's how I always try to build up my templates and kind of get to the tree structure to make sure that I get to a reusable solution, but also to a readable, maintainable solution by not putting all resources into one file. All right, so let's have a look at how we can then actually deploy the thing. And to do that, we're going to move over to Azure DevOps, because that's where I have specified a deployment pipeline to actually deploy it. I've defined my pipeline in YAML. Let me blow that up a bit. And I've defined 2 stages. So the first stage is actually pretty comparable to what you would normally call the build of your software. In your build, you would normally create the artifact that you can then deploy to your test environment, your production environment, or whatever environment you might have. I'm doing the same here in this publish templates step. This publish step, or stage actually, is doing nothing more than copying my templates into a blob container in Azure Storage to make it available for later use during deployment to any environment. Now, right over here in the deploy template step, I am deploying templates. And obviously, the most important step here is the Azure Resource Manager template deployment task. That's a task that is default in Azure DevOps. You just have to specify the template you actually want to get deployed, and you get to specify a parameter file in which you can specify your parameters and then have that be combined and deployed. So that's what a simple deployment pipeline could look like. Not too hard to get that done. If you want more details on how I've created the pipeline, then you can always go to my GitHub repository and find all the code, all the templates I've just shown you in this demo. You will also find the definition of this pipeline there for later reuse. All right, so if you then go into the Azure portal and have a quick look at what's the situation after you've been doing a deployment. So we're currently looking at a resource group in which I've been deploying my demo code. So all of the resources we just already saw, like the SQL Server and storage accounts and app configurations and whatever, have been nicely deployed into my storage account. And one of the features I find myself using a lot here on the resource group page is the one over here, the deployments. And I can actually click on it, and then I can see the deployments that have happened to this particular resource group. And I find this view especially useful if something goes wrong and I need to find the error message and need to figure out why something went wrong. Nowadays, most of the details that you find here actually are also being fed back into Azure DevOps and into your logs over there. But sometimes you get a very generic error message and not really the details, so that you can go over here to find the actual details to figure out what has gone wrong. And most of the time, the message is pretty clear, not always, but most of the time, the message is pretty clear on what's actually going wrong with the deployment of this particular resource. So that hopefully is a handy tip. So you might be asking yourself, how do I start writing these templates? It all looks a bit overwhelming, maybe. You need a lot of JSON to get something done. Well, what I often do is I just go into the portal. I create a resource like the storage account over here. And then I scroll down here on the left and find a feature that is called export template. And this export template over here will generate the ARM template to create this particular resource for you. So as you can see, this is actually quite big, quite a lot for just the creation of a storage account. you saw my version of the actual deployment was much smaller. That's because a lot of the default values on a resource are defined here in the templates. So you sometimes want to remove a bit of what is defined here to make it a bit more readable in your solution, but at least it gives you an impression of how you can do it. And if you would just copy and paste this into your version control system, it would actually work. So it's always a nice starting point to go here and fetch the template. One last thing I want to show you before we wrap up is the actual documentation on the ARM templates specification. And that has improved a lot over the last 2 years, I would say. So you can actually go here on this documentation URL, and then you can actually find all the definitions of all the ARM templates right over here. It lists the options you have, and it also further down the line specifies all the properties and options, etc. you have on specific fields, specific values. This piece of documentation is getting better and better every day, so I find myself using it a lot if I need to figure out why something is going wrong, or need to figure out how can I deploy a specific resource. Right? That's actually what I had to tell you today about ARM templates and my experience on that. The link at the bottom here is a link to my GitHub account with the demo you saw me using today. So if you want to reread, review anything you saw today, feel free to go over there and do that. You can also go to my blog. I wrote a few posts on ARM templates and how to use them, etc. And you see my Twitter handle over there. So if you ever want to ask a question on ARM templates or Azure in general, feel free to reach out. And I will probably respond quickest on Twitter. You can also use LinkedIn or whatever. So thanks for joining. And let's see if there are any questions.
Yes, thanks, Erwin, for the presentation. So there was one question from Vincent. Would you prefer ARM templates or Terraform?
That's a good question. As always, that kind of depends on your situation, probably. I've worked with both in different projects, and both actually work fine for creating resources in Azure. Sometimes writing a definition in Terraforms is a bit easier. You need a bit less typing to do the same work. So that might be a pro there. On the other hand, if you go for ARM templates, you actually get the whole definition. You can do literally anything you can do on Azure using an ARM template, and that's not always the case in Terraforms. So I would prefer ARM templates, but it's also because I have quite a lot of experience in them by now. But I do know there's a bit of, it's quite hard to get up and running with ARM templates in the beginning. And I find that learning curve a bit less steep for Terraforms. But there's actually a new addition coming to ARM templates. This is the Bicep project. That's a DSL on top of ARM templates, which actually looks a bit like Terraform. It looks quite similar in how you define your resources. That is, however, in a very, very early stage. Version 0.1 was just released, and they tell you not to use that in production just yet. But it actually looks quite similar. So I will probably start with ARM templates if I need to do a new project today, and then later on move on to Bicep to get the benefits of Bicep, but still be in the Microsoft ecosystem. That's a pretty long answer.
Yeah, thank you.
I hope.
I have one more additional question. We have still a few seconds left. So when you're using linked templates and pushing the JSON files to blob storage, do you recommend some kind of a version strategy for these files? What if you're pushing updates to those existing JSON files?
What I always do is that I always create a new blob container in the storage account on each build that I do. So that means you always get a new folder, so to speak, in your storage account with all the templates. So that allows you to always go back to a previous build. So I don't overwrite anything. I always create a new folder and do a complete copy of all the templates.
Good. One additional question: when you secure the JSON files with a SAS token, do you set a expiry date? What's your recommendation here?
Yeah, I do. And that's actually a bit of a nasty thing sometimes. I like to keep that expiry date quite small, but depending on how quickly you actually deploy your templates, that might not be long enough. And what I mean by that is that if I create a new version of my templates today, then that's being stored in a storage account today, and the SAS token is the one of today. But if it then takes a bit of time for that change to move on to production, that token might have expired. So there's a bit of thinking about how long should the token be valid. So there's a trade-off between usability and security and etc. But I do try to keep it as small as I can. Yeah.
Perfect. Thanks for your presentation again. And yeah, if people have other questions, just push them here in the chat window or contact Erwin by his Twitter handle.
Yes, please do. Please do.
Okay, good. Thanks very much for opening the VisugXL on stage 2, and talk to you soon. Bye-bye.
Yeah, thank you. Bye-bye.